Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting question, 2 to the power a plus 2 to the power a equal to 80. We need to solve this equation for a. So if you have your solution, your answer, you can also write it in the comments below, and in a few minutes we will check your answer. So it will be really interesting. So first of all, on the left side we have 2 to the a plus 2 to the a. We can easily add it without any problem, so we can write it as 2 times 2 to the power a equal to 80. And a lot of students might be asking, why can we write it like that? And here's my quick answer. So we have 2 to the power a. For example, 2 to the a equal to x. For example, yeah, just keep in your head that this equal to x. 2 to the power a, this is also our x. So we have addition, so we have plus x. When we add it, x plus x, of course, in terms of basic algebra skills, this is equal to 2x, yeah, and in our case we have the same thing, but instead of x we have 2 to the a, so we have 2 times 2 to the power a equal to 80. So I really hope you understand it. Second step, let's divide both sides by 2. Let's do this right now. So as a result we have 2 to the power a equal to, so we cancel it from the left side, and on the right side we have only 80 over 2 equal to 40. So 2 to the power a equal to 40. Here is our equation. But how can we solve it? On the first side we can solve it in terms of maybe this quadratic equation, but no, we have only power, so we can easily apply natural log on both sides, or log, doesn't matter. This is like up to you. I suggest you to apply a log on both sides. So we have log 2 to the power a equal to log 40. Okay, this is our expression. And why this is really great for us? Because we can easily write this a right here in front of this log. In terms of this property, so when you have log, for example, right here base of a, right here we have b, and we have a power c. So this power c we can write at this place of c log base of a. Right here we have b. So I hope you understand this property. Yeah. So as a result, we have on the left side we have a log 2 equal to log 40. Okay, so I hope you understand it. And right now, the final step, let's divide both sides by this log 2, because we need to find only our a. We don't need a product a log 2. So as a result, when we divide it by log 2, when we divide both sides, we have a equal to log 40 over log 2. And a lot of students might be thinking that this is our final answer. So we have our a without any problems. This is our final answer. And you know, this is a correct thing. Of course, this is final answer, but we can simplify this a little bit. First of all, this 40 can be written as, it doesn't matter if like 2 times 20 or 8 times 5, something like that. But I suggest you to write it as 2 times 20. Let's start with that. So we have log, and we have 2 times 20, and a lot of students might be asking why we express it as a product. And here's my quick tip. There is like a really important property when you have a log, for example, a times b, when you have a log of a product, you can write it as log, right here, I continue right here, when we can write it as log a plus log b. Okay, so log of a product equal as a sum of two logs. Extremely important property, and right now let's apply it. I'm going to continue right here on the left side. So we have equal to, so a equal to, we have log 2 plus log 20. Okay, log 2 plus log 20 equal to all over log 2. Right now, extremely important step. Let's divide our numerator by this log 2. Okay, so we can easily look like split it. Yeah, we can divide it. So log 2 over this log 2. Yeah, log 2, and plus log 20 divided by log 2. Right now, this log 2 over log 2, we can easily cancel it. So as a result, we have only our 1. Plus, but this log 20, we can split once more. We can express this as log 4 times 5. So let's do it. So log 4 times 5, and all over log 2. And right now, according to the same algorithm, we can write this one as log 4 plus log 5. So let's do it. So we have 1 plus log 4 plus log 5, all over, right here we divided by log 2. And right now, the second thing what we're going to do, we're going to divide once more by this log 2. So the same algorithm as we did before. So we have 1 plus log 4 over log 2, and plus log 5 over log 2. Right here, really important moment, because this expression we can easily write as log 2 to the power 2 or 2 log 2. Okay, so this 4 can be written as right here as 2 square, And these 2 we can write in front of it and cancel in log 2 with this denominator. So as a result, we have 2 right here. 1 plus 2 equal to 3. So we have 3 plus log 5 over log 2. And right now I see that this is a long way. How can we simplify it? How can we solve it? Of course, we can choose another option, maybe a faster one. Of course, we can write it. Maybe the faster method is to write this 40 as 8 times 5. Yeah, then we're gonna have like 2 cube. We're gonna cancel with this log 2. This is a faster method. When you write this log 40, I'm gonna write it right here. Oh, I hope you understand it. So this log 40, it's really interesting and it's really great to write as log 8 times 5. This is a faster method, but of course I hope you get it. I hope you understand my approach, okay? And of course we have our answer. So from here, our answer is equal to this one, 3 plus log 5 over log 2. So we have 3 plus log 5 over log 2. This is our final answer to our question. And if you're interested in approximately answer, maybe some students, interested in approximately answer, so A approximately equal to 5.32. In the second step, let's check real quick our answer. So let's prove it, let's check. So right here, I'm gonna write on the left side, so let's prove it. But to prove it, I'm gonna choose another option. I choose another like expression, because this answer, I wanna write it in a different way. I'm gonna write it as 3 plus this expression right here. I wanna write as log 5 base of 2. In terms of log property, we can easily write it like that. Okay, in terms of log property, we can easily do that. So right now, let's plug in this answer in our question. So we have right here 2 to the power a plus 2 to the power a equal to 80. And right now, let's plug in this answer to our question. Let's see. Maybe our root is not correct. Let's see. So we have 2 to the power a equal to this expression. So we have 3 plus log 5 base of 2, and we have plus 2 to the power the same a. So we have 3 plus log 5 base of 2 equal to 80. Right now, according to a basic power rule, we can easily split it like 2 to the power 3 times 2 to the power this one. So 2 to the power log 5 base of 2 and plus 2 to the power 3 times 2 to the power log 5 base of 2 equal to 80. And right now, a lot of students may be asking, maybe this is like a complicated way. How can we solve it? Because we have a log in our power. But if you know really important, really great property, so this one, I want to show you. I'm gonna underline this part right here. So here's a really great part, because we can easily cancel this expression. So when you have 2 to the power log 2, so we need to have the same constant, you can easily cancel it, and as a result you have only 5 from here and only 5 from here. So as a result, we have 2 cube equal to 8. 8 times right here we have only 5, plus right here we have the same 8 times only our 5 equal to 80. And I hope this is a great, correct answer, because we have 8 times 5, 40, plus 40 equal to 80. So this is a correct answer. So we can easily prove it, because our left hand side equal to our right hand side. So our root is great, but I suggest you to choose this variation, this expression. So change a little bit with this one, because it's much easier to work with this type. Okay, with this type in one log, not splitting by 2 logs. And the third way, not like the third way, I'm going to show you how can we find a little bit, maybe a complex root. So here's our question: 2 to the power a plus 2 to the power a equal to 80. And of course, as I said before, we get 2 to the power a equal to 40. And right now, I'm going to show you how can we. I'm going to say you few thoughts. How can we find a complex value of a? First of all, instead of this 2 to the power a right here, I want to write the next expression. So e to the power natural log of 2 to the power a. In terms of log property, we can easily do this, but in the same way, a can be written right here in terms of log property. So we have e to the power a natural log 2. So instead of this 2 to the power a, I want to write this expression. Instead of this 40, this is a constant, but in terms of our identity, in terms of complex numbers, 40 can be written as 40 times e to the power I to k pi. And of course, we are talking about k, like from the set of integers. And right now, instead of 40, we're gonna plug in this expression. Instead of 2 to the a, we're gonna plug in this one. But before this, I'm gonna split this by parts. I'm gonna split it, so I want you to see like a difference. I'm gonna do this. So first of all, 2 to the power a equal to e to the power a log 2, natural log 2, equal to, instead of 40, we're going to write this one, 40 times e to the power I 2k pi. Okay, this one. Right now, let's apply natural log on both sides. So we need to find this a from here. So let's do it. So natural log of e to the power a natural log 2 equal to natural log of 40 times e to the power I 2k pi. Okay, really great. Right now, this natural log equal to 1, and this power we can write in front of it in terms of the same rule. Okay, so we have a natural log 2 equal to, right now, this log of a product we can write as a sum of two logs according to the same property. So from here, yeah, we had it before. We write it as a sum. So let's do this in this case. So we have natural log of 40 plus natural log of e to the power I 2k pi. Right now, a natural log 2 equal to, right here we have natural log 40, but this one, this I 2k pi, we can write in front of it, so doing the same thing as we did before. So from here, okay, we write this power in front of it, and natural log equal to 1. So as a result, we have plus I 2k pi. This is a constant. This is like this is our pi. This is our imaginary unit. So everything is great on the right side, and we only need to divide both sides by a natural log 2. Oh, not like a by natural log 2, by natural log 2. Not, yeah. So we have a equal to natural log 40. So instead of this natural log 40, we can write a product. So this is up to you how you prefer like solving this question. Of course, we can write it as natural log 5 plus natural log 8. We can split it like that, or 2 times 20, natural log 2 plus natural log 20. So this is up to you. And we have plus I 2k pi. And all over, we're going to divide all of this by natural log 2. This is our variation of a complex root. Here you can see it. This is our imaginary unit. This is our imaginary root. This is our complex root. Of course, write your thoughts about this part. What do you think a little bit about it? And it's really interesting to exchange information in the comments below. Right here on the left side, I'm gonna write our final answer. So we had it before, but I'm gonna write it once more. So we have our answer. We can easily use both variations, this one or this one. This is up to you. Of course, let's use this one. A lot of students prefer this one. Okay, so we have a equal to 3 plus what do we have? Log 5 over log 2, and of course a approximately equal, maybe someone interested in this, so 5.32. This is our approximately answer. This is our real number root. This is our complex root. So this is a full solution to this question. Of course, write your thoughts, write your response in the comments below. Let's discuss a little bit about this question. What do you think a little bit about it? What do you think about this imaginary unit, imaginary root right here? What do you think about the solution? Maybe you have your faster method. Maybe you have your response, your feedback. It's also really great to see it in the comments below. And of course, thank you for watching. Take care of yourself and have a great day. See you in the next videos.